Okay, I've got 10 o'clock, so we should probably get going. I've got just about an hour's worth of material here. Welcome to today's presentation, Best Practices for Energy Audits, when we're going to propose a cold climate air source heat pump. My name is Mark Hutchins. If we haven't met, I'm a Training and Development Manager at Clear Result Consulting. I have the typical Clear Result email right there, and those are some of the certifications that I have collected over the years. All right, so what are we going to talk about today? So we're going to start out talking about the major components of an energy audit, and then we're going to look at the areas that we would evaluate, look at the diagnostic tests that you should do while you're at the home, which is probably more diagnostic tests than you are currently doing, okay? And we're going to talk about developing the scope of development for the project, excuse me, and then we'll talk about discussing setting the customer's expectations realistically, okay? So has everybody heard enough about cold climate air source heat pumps for one day or a day and a half, right? I think maybe I can get a little higher. How's that? Better? Yeah. Okay. Okay. So obviously, cold climate air source heat pumps aren't a new thing, right? Or heat pumps aren't new. The cold climate part is. My experience with heat pumps actually started in the early 90s. The first job I had was as an energy auditor was to go out and try to fix all the mistakes we made the first time. Okay, we had units that were designed to work in like Florida and Georgia. We stuck them in houses that were built during a building boom during the 80s. So the buildings were leaky, they were poorly insulated, and the duct systems were very leaky. Sometimes we couldn't even pressurize them with a pressurization fan, and they were poorly insulated, right? So the whole thing was a disaster. We know a guy who put in 40 of them in a development, and 2 years later pulled 40 of them out and put gas furnaces in. Okay, do we want that to happen again? Obviously not, right? What's different this time is we actually do have a unit that can work here where it gets really cold. We didn't have that before. Can we still screw up the other parts? Sure, right? We can do that. So let's not. All right, so let's wait. Let's look at the 4 components of the energy audit to start out with. All right, so the first one is the customer, right? The customer is sort of the wild card in all this, aren't they? We never know what they're actually going to do out there. And so this is the reason why, one of the reasons we have to set reasonable expectations for what the customer knows the heat pump can do or can't do, right? What's one thing about it when you go out there? Sometimes it's going to be a nice ranch on a slab, and we can get it really energy efficient and heat it very easily. And sometimes it's going to be a 150-year-old Victorian with rubble foundation and balloon framing and all kinds of stuff, right? So we have to develop a plan for the installation that works in any type of house that we encounter, right? Then there's the energy usage, right? We're going to try to get probably from some type of fossil fuel over to electric. Maybe it's a conversion. When it's electric resistance, it's almost a no-brainer, right? But when we look at other fuels, it has a lot to do with efficiency of the appliance and expense of fuel, right? Whether or not something is cost-effective or it isn't. And then finally, there's you, the energy auditor, and that can vary pretty widely also, right? We have very experienced energy auditors who know how to do a lot of different things, and we have energy auditors who are just gotten into the field, and their experience and technical abilities are somewhat limited, okay? I do teach building analyst technician and building analyst professional classes, and you need to get a 70 on the test in order to be certified, which means that there is stuff, even though you took the class, you still don't know, right? And so we have different levels of expertise of energy auditors. And you should be doing a visual inspection out there and doing diagnostics also. All right, so every assessment is going to begin with a customer interview, right? Is anybody who actually here does energy audits, goes out? Okay, good. You ever go to the energy audit, ignore the customer, and just start walking around their house? Of course not, right? It always starts with a discussion with the customer. And one of the reasons we do it is because not everybody does things for the same reason, right? Most of the time, it's either a comfort complaint or a bill complaint. That's typically what brings us out there, right? Sometimes, though, it's health and safety. It can be something like that. Or building durability. So those are probably the 4 reasons we go out. But everybody does things for the same reason, right? And that's true about cold climate air source heat pumps, too. What's a reason that someone might want to go to a cold climate air source heat pump that wasn't typically a reason why they called us out previously? What are they thinking about?
They heard about it on the radio.
Well, yeah, adding air conditioning, little climate change. Right? People are always thinking, I want to go from my fossil fuel system and electrify, and that will help with my carbon footprint, right? So that's one of the things they think about, right? Their carbon footprint. One of the reasons we've always gone out there is lower cost of operation, right? They've heard that switching over to a cold climate air source heat pump could save them money. Maybe it will, maybe it won't. We'll see, right? Right. So money is another one, savings. There's no denying that electric heat is safer than gas or propane, right? We don't have a lot of gas explosions, right? But when we do, they're pretty traumatic, right? The house is destroyed. Oftentimes, people do die, and so all electric is definitely safer. And then there's also, the concern about producing carbon monoxide and having that pulled back into the house if the appliance backdrafts or something like that. So it's safer. And then what somebody mentioned back there, they just want to add cooling, right? It gets pretty hot in central New York and different parts of the Northeast, even though we're considered a cold climate during the summertime, and it's humid, and they want to be more comfortable, okay? So we find out what's the motivation for going to a cold climate air source heat pump, and then what we want to know is, what do they really know about cold climate air source heat pumps? What's their level of expertise on that? Switching over to a cold climate air source heat pump will only help you with climate change if what? It'll only help you with climate change, switching over to an electric source, if your source of power uses a lot of renewable energy, right? All you're doing is displacing it. If your utility is making power with natural gas, coal, and oil, you haven't actually helped the climate. You just moved the process over there. So the net gain really isn't there. It only really matters if your utility has a lot of renewables or something that's non-carbon producing. Okay. Do they have any idea how much it will save them? Maybe who said radio ad, right? I can save you 40% on your heating and cooling bills. Hurrah, right? They're for it. Will it really save them 40%? It depends, right? What are they heating with? How efficient is the furnace or whatever they're heating with? What's the cost of the fuel, right? That's what's going to determine whether it saves them money at all, okay? Do they have any idea how much it will cost to install them? That's variable, right? Depending on how big a system, how difficult the install is. So do they have any idea, and do they have the budget that actually matches that reality? Okay. And then the final thing is, how intrusive is it? Some people think that we can just bring an appliance in, we'll take the furnace out, we'll slap the air source heat pump in there, we'll turn it on, and off we go, right? That's probably the rarest situation you're going to see, right? There's a lot of other things that have to happen correctly in order for that to work, okay? So after we have this conversation with them, what we're hoping to know is how committed they are to moving on and actually installing a cold climate air source heat pump. Or are they just tire kickers? They heard about it, they were sort of interested, we had a conversation, they say, nah, not for me, or they say, yeah, that sounds great, let's go. And so once you have that conversation, you kind of have some idea where we are. Now, if the domestic hot water system that they have is somehow tied to their heating system, like a tankless coil off the boiler or an integrated tank or something like that, and you plan on getting rid of the boiler, then we need to have a plan for domestic hot water also, right? They'll still need that. And so, you could leave the boiler in place and maybe keep the integrated tank and use the boiler as backup heat, right? Or emergency heat. Or maybe you can start thinking about heat pump water heater or something like that, something that works for them. I wouldn't recommend an electric resistance tank because obviously that's the most expensive way to make hot water. So don't go there. Okay, so the house and the inspection is pretty much the same as it normally is, but we're going to look at things in more depth and do more analysis and more diagnostic tests, because the person who's going to actually design and install this system is going to need a lot more information from you than we normally get. Now, there are a lot of different types of audits, right? There's clipboard audits and there's very intense audits. I'm not sure what type everybody here is doing, but the audit I'm going to describe is the one that we need to do in order to get the information we need to actually design and install this, okay? And so what I'm going to talk about throughout this is the things that need to happen, not necessarily to be done by you, but by somebody, right, in this process somewhere, okay? So the usual stuff, the blower door test, how leaky is the house, find the primary air pressure boundary, seal it up as tight as we can, make sure the insulation touches it. We want to measure up all the different surfaces because they're going to need to go into a heating and cooling load calculation, right? We have to do that as one of the first steps to actually figuring out how big the system's going to need to be. We want to do a look at what's existing there for mechanical systems, what type, how efficient, fuel type, the distribution system also, if there is one, right? Ducts, how good are they, how leaky are they, how well insulated. We want to separate the base load from the seasonal loads to see how much they're actually spending on heating and cooling. And then we're going to get into combustion safety testing and then all of our diagnostic tests. Who here does duct leakage tests on a regular basis? No one, right? Once in a while? Yeah. Who here knows how to do one? Oh, good. That's good. Because you're going to need to do one. And then airflow testing also. We need to know how much air is flowing through this whole system, right? So we can make sure that we have the overall airflow that we need. But we also need to know on a room-by-room basis how much air is coming out of each supply so we can see whether or not we can send enough heated air to that space to condition it. Okay, we want to look at the energy usage. Like I said, separate seasonal from base load. What's their existing fuel type? Because that has a lot to do with whether or not something is going to actually pan out from a cost-effective point of view, and also from a climate change also. And then we can look at what their options are. Fuel switching to natural gas or moving to a cold climate air source heat pump. Obviously, today we're talking about going to a cold climate air source heat pump, right? Oops, I think I jumped one. Sorry about that. Here we are. Okay, and then the final part is you. And as I was saying before, years as an energy advisor and level of experience, okay? Certifications that you might carry. I had a bunch there. I don't put a lot of stock in certifications, not nearly as much as I put in experience and curiosity, okay? Curiosity is a big thing. I learned almost nothing in the first 2 weeks that I was trained by people who really didn't know very much in the first place, because it was 1992. Over the years, my curiosity has led me to learn a lot of different things that aren't necessarily part of being a building analyst technician, okay? So what's your curiosity factor? And then your diagnostic toolkit. What tests do you know how to perform? Most of you know how to perform a duct blaster test or a duct leakage test. That's good, right? You have one of those skills in place. Blower door test, obviously. And then, soft skills. How do you deal with the customer and the other contractors and that sort of thing, right? Soft skills are important. One of the things I knew when I was an energy auditor was that every day I was going to go out and meet a whole bunch of people I'd never met before, right? And I had to find a way to be able to, communicate well with them and find some type of common ground regardless of who they were. Okay, so soft skills are important also. All right, so these are the typical components of the project, right? Sort of the BPI way. The site inspection, we're going to do the customer interview first, exterior walk around, interior walkthrough. We're going to do our combustion safety testing. Once we know it's safe to work in the house, we'll start the shell assessment, the blower doors, and all that sort of stuff. We're always looking for roadblocks, right? Lead, radon, et cetera. And we want to remove those so we can move forward. We're going to take all the information we gather from the site, and we're going to put it into our modeling software, and we're going to come up with a cost-effective work scope, right? A list of cost-effective measures. And then we're going to say evaluation and upgrade, right? If this house doesn't have an air conditioning system there already, it most likely doesn't have the amount of power it needs to install air source heat pumps, right? They need the same thing. They need a 200 amp service. So we have to take a look at that, see what they have, and that might become part of the upgrades that we have to talk about. We did an in-depth evaluation of the duct system, okay, if it has one. It's not it's a duct system. It's got R6 on it. Good to go, let's go, right? That won't fly anymore. We need to know that this duct system can deliver the amount of air to the space at the temperature we need in order to condition that space. If it can't, or we don't think it can, we have to fix it. We can't just hope for the best, okay? Deep retrofit heat load reducing measures. We may want to consider doing things we never considered doing before, right? I know that in the Massachusetts program, they're adamant we don't do spray foam, period, okay? They need to start thinking about spray foam, not all over the house, but maybe the band joist, right? Get the band joist nice and tight, with targeted spray foam, different things like that. So we need to think about load reducing measures we haven't thought about before. Heating and cooling load calculations, okay? Is the necessity to do heating and cooling load calculations unique to cold climate air source heat pumps? No, it's not, right? This isn't new. Nothing I've said here is really new, right? Every system, before it's installed, should have an accurate heating and cooling load calculation. This right here is why we need to gather more data on the house. We need to know about the windows, the direction, the type they are, the shading. All that sort of information has to come off of your site visit. Somebody needs to design it, okay? It's great to have a heating and cooling load calculation, but there are other parts to it. We need to take that and take the procedures in Manual S, ACA's Manual S, apply those to the load, and pick the right unit. And when we do that, we also have to design the duct system, and we have to think about zoning and matching up the units exactly, or as exactly as we can, with the loads that are in each room, okay? This idea that we can do one outdoor unit, one indoor unit, one outdoor indoor unit, that's not the way to go, okay? That's expensive, first of all, and you get oversized. We can't do it that way, all right? And then finally, when we're done, we want to start it up and make sure it works correctly, right? That's the contractor, obviously. Okay, so let's talk a bit more about the inspection. All right, so most people here are auditors, and we know up front that if you show up to the house and the first time you open the file is when you sit down with the customer, are you prepared? No, you basically have no idea what's going on there, right? You want to take a good look at the file before you ever get there, familiarize yourself with it, know what the customer's name is, and greet them by their name when you knock on the door, right? Know that they have children, pets, that sort of thing if it's in there. Make sure that the paperwork's up to date, whatever's supposed to be in there as far as programmatic stuff is if you're in a program. Also verify you know where you're going, right? One of the things my partner and I always did to make sure we weren't late was we always gave ourselves a little bit of what we called squish time, right? So if something said it was going to take us, a half an hour to get there, we would give ourselves 40 minutes, for traffic and problems. And if we had to pull over for 5 minutes, down the road from the house to make sure we showed up on time, we did, right? So make sure you know where you're going so you don't show up late. This is a great idea if your program allows you to call the client the day before and just verify and confirm the appointment, all right? And so it makes time, also the length of the appointment. Do you ever show up to do an inspection or an audit and you're thinking this is going to take me 2 hours and the customer's thinking this is going to take you 15 minutes, right? Yeah. So we want to, if we can, we want to confirm all that. And then this one's pretty obvious, but it happens. Make sure you bring everything that you need to actually perform the testing you're going to have to do, right? I'd like to say that's a no-brainer, but my brother always screwed that up, drove me nuts. Okay, so you pull up, and the assessment really begins the minute you pull up, right? So what style is the house? Is it my favorite house, which is the ranch, or the house that I hate the most, which is the Victorian, right? Is it the house that was described in the file? How many stories high is it? What type of siding? Site restrictions are a big thing, right? If we need to get a truck into the backyard or close to the house, is there anything stopping us from getting there? Real steep driveways, right? That getting a cube up a real steep driveway is tough. Or there's trees hanging over wires. So, are we going to have some type of problems with that? Does anything about the house jump out at you as far as really maintenance goes, right? It's nice to see houses that are well maintained, and houses that aren't, that's okay too. But we don't like to see houses with like broken windows, and all kinds of structural problems and things like that, right? Where the soffit's rotted out over the years and it's fallen down, stuff like that is kind of a warning sign. Okay, so is it a house that was described in the file? For me, basement type is a big thing, right? Is it a concrete foundation or is it a rubble foundation? Because concrete foundations are monolithic, and you can tighten them up if you'd like to. Rubble foundations are a different story. Air comes right through them, and they're difficult to make airtight. Okay, so right away, when you have a rubble foundation, by rubble I mean stone, right? You're going to have problems getting the house tight. Balloon or platform framed. Platform frames we can get tight pretty easily, right, with our typical air sealing measures. Balloon frames is a problem, especially if there's insulation in there, right? If we want a dense packed balloon frame to get the house tighter, If there's no insulation in there, we can do that successfully. If there is some insulation for some reason, it's harder, obviously, and sometimes not possible. Garage is important, right? If it's attached or underneath, then we have to think about air sealing to push that out of the conditioned space, right? Doing air sealing that's not actually going to save money. Existing fuel types. The intake says that it's oil, and you pull up and there's a gas meter, right? So verify the fuel types. And then, different types of house features that make the house more difficult to make tight. Porch roofs tying in, cantilevers, bump outs, all these sorts of things, especially in these older homes. You never know how they're framed and how you're going to get those things tightened up. And then again, electric service, and then dogs and things like that. Anybody ever get attacked by a dog when they're doing the audits? Yeah, that was always my first thing, was look around to make sure there wasn't a dog somewhere. I love dogs, but I don't like dogs that bite me. I like them less. Okay, so a good auditor is an observant one, okay? And so when we pull up sometimes, we can see different things going on in a house. A little bit of ice damming there, that's probably melt off from the skylight. But what we see here is this pattern that tells us that the knee wall is probably outside the conditioned space. So it's a knee wall attic, it's not in there. But we can see that the slope, for whatever reason, doesn't appear to be very well insulated. There's either none or very, very poorly insulated. We can see the melt on the roof, right? And so just already we know that this area over here doesn't have insulation in it, okay? And so sometimes, what happens sometimes when you have really cold surfaces in a house? Condensation and then mold, yeah. So we want to watch for stuff like that, right? Cold surfaces that might be growing mold. Okay, and that kind of leads us to moisture in general, which is always a problem, right? We need the house to stay dry. When we look at this house over here, we can see that the grade is all coming towards the house, which means the water's going to run towards it. But they seem to know that because they've put sort of a hard pan here to drain that off, and the same thing over here. We don't want standing moisture in the basement, right? Because standing moisture evaporates, and when it evaporates, it comes up into the house. And if we tighten the house up significantly, then we're going to trap that moisture, and we'll have created a moisture problem. Okay, so this is a porch roof intersection like I was talking about before. And if this is a problem or not really depends on how this house was framed. If they framed the house and then they framed the porch and attached it to it, then the exterior walls will be sheathed, and there'll be a transition blocker here. But if they framed it all at once, the bottom of that wall won't be sheathed, and most likely the floor joists will be cantilevered and unsealed, which means that when ventilation air flows up into this porch, it's going to go between the floors, just like a knee wall, okay? Access obviously is a problem there. So just details like that are the sorts of things that we need to look at or think about anyway. How could we discover whether or not this is framed correctly or not? What's that? I couldn't hear you. Yeah, you could do that, sure. You can also do it with like an IR camera and a blower door, right? If you don't have a borescope. Okay, so when we do our audit, we have three main areas of focus, right? We have the attic, then we have the main living space, which is typically, hopefully, conditioned space. Then we have basements and crawl spaces, right? So we have the conditioned area and basically buffer spaces off of it that we need to deal with. So this is probably something that you've learned, especially now with digital cameras and stuff. It's so easy to take a picture of anything that you want to describe to somebody, right? So they've always said that a picture's worth 1,000 words, and sketches are pretty good too. One of the things that I always did when I did an audit was we had to figure out what the wall areas and ceiling areas and that thing was, because we were always specifying insulation. So we would just start in one corner, and we would measure out a sketch on a piece of graph paper, and we would dimension it, and then we would put all the different details on it. Now, doing this actually helps out in a couple different ways, right? This helps out the air sealers, right? If you do an interior walkthrough and you put the stuff in here, because it's a lot easier to find air sealing details from inside the house than in the attic, right? It's easy to see a recessed light from down here, not so easy in a dark attic when it's underneath the insulation. So, drop soffits, masonry chimney, wet walls, isolated top places they might not find, that sort of thing, are all things you can put on a sketch that helps the air sealer. But also when you want to talk to the customer about things you're proposing, having the sketch is very helpful too, because you can point right to what you're talking about. Okay, older homes and newer homes on crawl spaces oftentimes can have dirt floors. This is a sort of thing where we want to go from the dirt floor to the class 1 vapor diffusion retarder, 6 mil poly, right? We'd like to pull it up the walls and attach it with either 1 part foam or duct mastic, and then seal all the seams nice and tight. Make sure all that water vapor stays down in the basement like it's supposed to, or underneath the tarp. Okay, so bad ideas and poor workmanship equals cold climate air source heat pump failure, okay? What is that? That is an unfinished basement with a return in it, okay? In an old home, okay? They probably added this because they didn't have enough airflow through the system, and so doing that gave them more return flow, which improved the flow through the system. Good idea to improve the flow, bad idea to take return air from unconditioned space ever, right? Where is return air supposed to come from? The house, the living space. It comes from conditioned space, it goes through the unit, and it goes back to conditioned space. This is nothing but a gigantic return side leak in a space that has 2 category 1 natural draft appliances. What could go wrong, right? This is the kind of stuff we have to stop. We've got to seal these up really tight, and we can't have this like panning and this type of leaks, right? This panning is right up against, it's not resolving really great on the screen. This is a rubble foundation in an old home, and this panning is right up against where the shoe plate is sitting on the rock. Now, this is typically a tight space, right? Rock's nice and level, there's no leaks there, right? Its leak is all heck. So when this is running and it's really cold out, where is it getting a lot of its return air? Outside, right? It's 20 degrees outside. You're pulling this in, and the air that's now flowing to the unit, your air source heat pump, that's supposed to be 70 degrees is now 50 degrees. Your air source heat pump has a 30-degree temperature rise. It's supposed to go from 70 to 100, not 50 to 80. You told them the air coming out wouldn't be as hot. You didn't tell them it would be cold, right? We can't have this. We have to have tight ducts. Obviously, that's against code now, but it wasn't. But we can't have that kind of stuff going on. We have to take all the air from the conditioned space, because it's 70 degrees, and we have to push it back into there, because we need that 30-degree temperature rise to get to 100 degrees. We can't come to 80, okay? It's not gonna work. Close that, remove it, and seal it permanently. Okay, so what's the R value of the attics that we run into? It's the rare attic these days that if people have access to an attic, they've been in there, haven't they, right? They put stuff all over the insulation, they've thrown the insulation around. Maybe they had some extra insulation, they threw it on there. So we need an accurate estimate of what that insulation level is, and then we're gonna bring it all the way up to at least code anyway, okay? So we need to identify opportunity when we see it. Is this knee wall inside or outside the conditioned space? What determines what's conditioned space? The insulation and the air barrier. There is no insulation, right? Where's the air barrier? I don't know. It's balloon framed. Could be anywhere, right? But there's opportunity here. We can either pull this inside or we can push it outside. But we've got to do something. And when we do it, we better do it right? As tight as we can get it and as much insulation as we can get there is what we're trying to do. That's my favorite attic right there. Good walking space, almost no insulation, nothing blown in there. You can seal it up nice and tight. Huge opportunity there, right? To blow in another 15 to 16 inches of cellulose on top of that and bring it up to R49 or even R60. Okay, ducts in unconditioned space. There's a lot of different types of unconditioned space, right? There's ventilated attics and garages and ventilated crawl spaces, which is really bad unconditioned space because all the heat that you lose there is actually gone. And then there's basements and unvented crawl spaces and things like that where the duct loss isn't quite as bad. Okay, so we can see this poor soul is underneath that insulation there. Is that a saved? Should we save that insulation? What should we do with that insulation? Yeah, take it off, get rid of it. Because what it's really doing is it's just stopping us from accessing a bunch of leaks, right? And it's in terrible shape. You can see it's really old, it's fallen apart. He's ripped it up. Just take it off, seal that duct system as absolutely as tight as you possibly can, and then insulate it at least to code. What's code in an attic? 8, R8, okay? The International Energy Conservation Code's attic insulation on ducts should be R8, and the other space it's R6. Do you have to stop at code? You don't, right? The code is the worst house you're legally allowed to build, okay? That's what code means. You can do better than code, it's okay. If this system is down on the floor, we can blow insulation right over it and push it right inside, right? Attic accesses are always a weak spot. We know that code says that the access should be to the same R value as the building component it's part of, but there's no way we're building an R49 pull down staircase box, right? Can't do it. Best we can do is probably about R10, R14, something like that. So that's what we do. When we see accesses like this, what's our plan for getting that tight and well insulated? I'm asking you because I don't have one, right? I don't know what to do with that. It's a mess. What I would recommend is just pulling those doors off completely and putting a hatch there with barrel bolts, right? That way we can use Q-line with carrier around it to make it tight. We can put a couple of inches of high R board on the back, and now it's the same as the assembly that it's part of. Okay, that's the way you'd want to go there. Okay, so remember that porch roof we looked at before, and I said this could be a problem? This is that porch roof. It is a problem, okay? When we pulled the sheathing off and looked inside there, that's the bottom of the wall right there. It never got sheathed, which makes it susceptible to wind washing, right? So when the ventilation air comes up into this porch area, it's going to go over there, and it's going to wind wash that. And then here we can see the transition, right? Those are the floor joists of the second floor, and there is no blocker in there, which means that the air that flows up into that space goes back and forth between the floors and obviously robs it of R value, okay? Those are the sorts of things that we're looking for. What are called key details, right? So things like cantilevers, knee wall transitions, porch roof junctions, they're hidden details of the house that if we don't address them and make them tighter and better insulated, then a lot of the work that we do trying to make the house tighter never really helps, right? We have to address these sorts of key details. Okay, probably seen this before. So this is, insulation has a nominal R value, which is what it says on the package, right? So it's based on its depth and its R value per inch. And then it has an effective R value. How does it actually perform when it's installed, right? And so we do rate it good, fair, or poor. And so typically good is perfect or to manufacturer specifications. And then, fair and poor are something less than that. If this is in an attic, when I come up in the attic and I blow insulation over the top of this, what happens? All the gaps get filled, right? All the compression doesn't matter. And it goes from being poor to good. One of the things we are going to need is a pretty good estimate of the U factor and the solar heat gain coefficient of the windows. Now, the best way of getting that information is from an NFRC sticker, but those are temporary, right? And we're not at new homes, we're at existing homes. So what we want to do is we want to look at the window itself, make sure they all work and lock correctly. But we also want to look at the frame material. Is it wood, vinyl, metal, or fiberglass? Then we want to look at the number of panes of glass and determine whether or not it has a low E coating on it, okay? Does everybody know how to find a low E coating on a window? How to detect that? No? Okay. So there is something called the spectrally selective metering device. It's about $140. You can put it up against the window, pull the trigger, and it'll tell you if there's a low E coating and what surface of the glass it's on. If you don't have one of those, if you have, say, a double pane window, you can take an LED flashlight, shine it on the window. It's a white light, and you'll see 4 reflections of the 4 surfaces of the glass. If 2 of the inner ones between the panes is a slightly different color, blue, red, yellow, it doesn't really matter what the color is, as long as it's a little bit different, then it's a low E coating, and you can tell, okay? Low E coatings significantly affect how the window performs. So let's say we have a vinyl double pane window, right? We can come down, there's vinyl, there's double pane. The U factor is 0.46, and the solar heat gain coefficient is 0.57. But if it has a low E coating, it drops significantly to 0.36 and 0.45, right? Windows are the main driver of cooling loads, so that's important, right? If the solar heat gain coefficient is much lower or much higher than we think it is, then when our calculation for cooling is going to be off significantly. Okay, we're always looking for roadblocks, right? Obviously, knob and tube is a problem because we can't insulate up against it. That's forbidden by the National Electric Code. And we obviously don't want to start a fire either. Mold problems, things are not vented correctly. We need to look for all those different things because we have to remove those so we can install the measures that we want to. And then we get through the whole thing, we get to our customer report. So the energy step is the first step, and it helps us look at what the house needs to put together that prioritized list of upgrades. And in the past, it's been more simple than it is now because our upgrades may include more things to get this house ready for a cold climate heat pump. Okay, the report that comes out is helpful to the customer because if we prioritize it, then it kind of gives them a roadmap of what do they need to do and what their next steps are. Right. The list should always be prioritized. We don't want to come up with a list of 15 things, and the top one is pipe insulation, and the bottom one is air sealing. Right. It needs to be prioritized, bang for the buck, or health and safety things that they should do next. Now, you had a conversation with the customer, and they told you what their concerns and their motivation was. Reflect that in the energy audit report, okay? If you're at the Rockefeller's house, and they tell you they're concerned about climate change, don't hammer away at cost savings, right? Doesn't make any sense. Look at, what were their concerns and what motivates them, and tailor your report towards that. Okay, especially if they had custom comfort complaints, you definitely want to address that, regardless of whether it was valid or not. Okay, let's talk about diagnostic tests now. Okay, so small, tight homes that have good ventilation are where we're going to have problems with combustion safety, right? Because we can easily depressurize them, and oftentimes they don't have enough combustion air flowing to the Category 1 appliances for them to burn cleanly, okay? So who's been out to a house, ranch house, and done a blower door test on them, and it's been like 1,200 CFM 50? Happens, right? Small ranch, 1,000 square feet, happens all the time. Oh, who's been out to do an audit at a house, the small ranch, 1,200 square feet or so, and the CFM 50 has been like 1,200 or something like that? Yeah, happens, right? So you only have to blow 1,200 CFM out of that house to depressurize it to negative 50. If this house has a bath fan, a kitchen fan, and a typical dryer, people come home from work, someone's taking a shower, someone's cooking, and they're doing a load of laundry. You're expelling 600 CFM from that house. What happened? Good. It went pretty negative, didn't it? Right? And if you have Category 1 appliances there, chances are really good they're going to backdraft. We have to be careful of those tight homes that are well ventilated, right? That's just spot ventilation that could cause that kind of problem. So combustion safety testing is very important.
What do you mean by well ventilated?
Good ventilation, good spot ventilation, right? I'm not talking about attic ventilation. I'm talking about kitchen fan, bathroom fan, and a dryer.
Exhaust appliances.
Yes. Yeah. Anything that takes air from inside the house and expels it to the outside will reduce the pressure in the house significantly if it's tight. Okay, so the blower door is obviously our main diagnostic tool. It has been for years. And it tells us how leaky the building is. And we can take the CFM 50 and turn it into ACH 50 or ACH natural, right? And get a good idea of how tight it is. But it doesn't tell us where it's leaking, right? What we really want to do with the blower door after we have that number is leave it running and do some pressure diagnostics. And what we're looking for is where is the primary air pressure boundary, right? Where is it? Now, most houses we know it's going to be the outside walls, obviously, right? But when we look at the attic, is it the attic plane or the roof? When we look at the basement, is it the frame floor or is it the walls? Where is the primary air pressure boundary? Because wherever the primary air pressure boundary is where the insulation has to be, right? I went out to a lot of new houses when I was a home energy rater, and we do a blower door test on it, and the insulation is here in the frame floor, and we do a pressure diagnostic to the basement, and it comes back at like 4 or 5. And what that tells us is the pressure boundary is here, and the insulation is there. So what does that mean? It means it's not working, right? In a brand new house that people just bought. Okay, so we want to do those zonal pressure diagnostics, figure out where is the primary pressure boundary, and make that as tight as we can, and then put as much insulation as we possibly can right up against it, right? Continuous and aligned. We can do pressure pan testing. We can do it on the duct system, and we can also do it on exterior walls and interior wall plates. I'm going to talk about that a little bit more in a few minutes. And then we can do our walkthrough, figure out what are the things in there from the inside. When we look up at the attic, they need to be sealed. I talked about that a few minutes ago. And we're looking for visible leaks that we can see, but also those key details, right? The cantilever floor, the porch roof tie-ins, the tubs in the exterior walls. Those are the hidden, hard to get to leaks. We always do our air sealing. We always start high, right? Why do we always seal high in the house first? Stack effect, yes. Stack effect is the dominant way that a house leaks. We also have wind and we have mechanicals, but stack effect is always going on. So that means the leaks high and low are the most important. Not that the ones in between aren't, because when it's windy, they will leak, and when mechanicals are running, they'll leak. But it's high and low first, and then if there's opportunity and time, seal the ones in between. So most houses basically leak in the same place, right? So we're going to start high in the attic. It's pretty rare to go out to a house and say, wow, top plates don't leak here. Wonder what happened, right? The top plates, they always leak. The recessed lights, they always leak. House always leaks in the same place. So we always go to the same places, right? Major bypasses into the attic, key junction leakage areas. So we go high, then we go low. And then we look for any large leaks once we've gone high and low from the living space to the exterior, somewhere between where it's really high negative pressure and really high positive pressure. We can still look for those leaks also, okay? Blower door guided air sealing is really the way to go. You can, if you want the homeowner to be able to see it, right, rather than depressurize the house, pressurize it and then use smoke, and the smoke will go right to the hole and go right through it. And it's much easier to find leaks when you pressurize the house with smoke. If you depressurize it, it just kind of blows at you, but when you pressurize it, the smoke will go right to the hole. You can see it much more easily, and the homeowner can see it too.
But typically the blower door is depressurized.
Yes, yeah, you'd have to spin the fan around.
Do contractors do that?
Probably not. Well, that's one of the reasons why we depressurize instead of pressurizing. That's a good point. Is when you depressurize, it cools the whole house off because the air is leaking in all over the place, and the whole temperature comes down. When you turn that door around, if it's 10 degrees out, and you start blowing, 1,200 CFM into the kitchen, the temperature in the kitchen goes way, way down really fast. The customer is very uncomfortable. So that's one of the main reasons why we don't pressurize. Is just comfort for them. But you can, and when you pressurize, it's much easier to find the leaks with smoke. Okay, so these are IR pictures. These really aren't coming out that great, huh? It's just not projecting well on the screen. But this is, you can use the blower door and the IR camera. So what you do is you just take a look at the house with the IR camera before you run the blower door, then turn it on and depressurize the house for about 5 or 10 minutes. If you have enough of a delta T, you'll actually start to see like fingers of black cold air coming in. This is a base plate on an exterior wall that was never sealed, and you can see the cold air being sucked in. This is an interior wall. That's an electric plate and a thermostat, and you can see those cold fingers of air coming out of there, indicating to me that the top plate is not sealed. Okay, so I can determine, like if, say I went to a house and it had 16 inches of cellulose, and I didn't want to crawl out there and find out if the top plates were sealed because I don't want to ruin the work. I can find out whether they're sealed or not by doing this, without ever going in the attic. Okay, here's our pressure pan test. So like I said, it can be used on walls for zonal testing. So you depressurize the house to -50 pascals, attach your pressure gauge to the tap, put it over a wall outlet on an interior wall. If the reading is more than 3 pascals, then it probably means that the top plates are not sealed, and you should suit up or get somebody to suit up and go seal them. If it's less than 3 pascals, it's probably not worth going after. Okay? You can also do that on the exterior walls to see whether or not it's a good candidate for dense packing. It can be used on ductwork, like you can see this guy doing right here. So once again, push the ducts as outside as you can, open up the basement door, that sort of thing, so the ducts are outside, pressure-wise. And then the same, what he's doing right here, pressure gauge, and put it over the supply. And with the ducts, we're looking for a really tight number, right? Less than 1, right? If we go around and each of these readings is less than 1, you don't really know how tight the ducts are, but you know they're pretty tight. Probably not good candidates for duct sealing, okay? It doesn't quantify it, but it tells you how tight they are. It'll also tell you where they're leaking, right? If I come to this branch and it's 0.1, and I go to the next branch and it's 4, that tells me that this branch is tight. I don't need to worry about it, but there's something going on with that one, and I can go look at that one and seal that. Okay, so it tells you where. Okay, if you're doing an IR scan, when you look at a house and it looks like that, that's pretty good, right? There's not a lot of leakage there. There's a little bit over here. I think they had trouble getting the insulation to touch the drywall there, and that's what you're seeing there. And typically, if you were to see that with the drywall off, that's what it would look like. Okay, that's a good installation right there. A lot of times you'll see they'll side staple this, they'll push it in and side staple it. When you do that, you ensure compression on at least 2.5%. It should never be side stapled, always pulled over and face stapled. But you see no compression, no gaps, face stapled. That's a really nice installation. Okay? As opposed to this one where we can see significant black down in here, and that's telling us that's around 60 degrees. Something happened down here. They didn't push it in far enough, or they compressed it too much. Something happened. And so we see a weak spot there that we'd like to fix, right? But we have to figure out what's going on there. Okay. Okay, so when we go to a house and we're thinking, or the homeowner's thinking that they would like to install a heat pump, then we're gonna have to consider some measures that we usually don't, right? Higher levels of insulation. Code says you have to put in R38 or R49 in the attic, right? We have to listen to code, right? But it's always okay to go higher than code. It's just not okay to go less than code, right? So if you can get more in there. Why do we put so much insulation in the attic and not as much in the walls? No, we do it because we can. We do it because we can. We can do it, right? We've got the room, we've got the access. You can't do it in walls or floors. If we could do our 60 walls or our 49 walls easily, wouldn't we? Of course we would, right? The air does flow up there, right, and go out through leaks and stuff, but air sealing takes care of that, right? The insulation is to stop heat loss by conduction. And so there's no reason for the heat loss by conduction from the ceiling to be greater than the walls. It's the delta T that drives that, the difference in temperature between inside and outside. So if we could get R49 in the walls, certainly we would, but we can't, okay? We want to get as much insulation as possible. Our blower door tests, figure out how leaky the house is, use pressure differentials to find the primary air pressure boundary, and data as tight as you possibly can. If you need to add ventilation, right? Don't let that be your threshold anymore. If there's no pre-existing central AC system, we have to look and see what the amperage is on the electric panel and see if it's not 200 amps, then most likely we're looking at an upgrade, okay? The duct system, is there a duct system? If there isn't, we're going to need to install one or do ductless mini splits. Ducted systems, when they're done correctly, will probably deliver better comfort than ductless systems, okay? Because the ductless system, is distributing from one place in a big room or a good-sized room. Distributing the heating and cooling from one place can have you have entrainment problems and mixing problems, right? So when you can have a really good duct system that does what it's supposed to, that's better than a ductless system. Ductless are great because you can install them without a duct system in places where you normally wouldn't be able to put heating and air conditioning like that, right? It's a great retrofit. Okay, we need to gather all the information that the designer of the system needs in order to do the load size and the equipment selection and figure out whether the ducts work or not. This is absolutely critical to success. Okay, we don't do this part right, it's not going to work. Go ahead.
What about fan coil units inside instead of the duct system using hot water?
Yeah, you mean like up in the wall?
Even be along the floor where the baseboard.
Oh, inside of a baseboard.
Yeah.
Well, that'd be forced hot water, right?
Yeah. Rather than a duct system.
But that wouldn't be a heat pump though. That'd be a boiler or
Yeah, you can use it.
water to air to water. Yeah. You could do that. Yeah, you could do that.
You don't see that much, right?
No, I haven't seen it at all yet, but I think they're really starting to perfect the air to water, and you may start seeing it soon.
The big problem currently is they can't get the temperature rise.
Right.
They're talking with the new refrigerants possibly being able to do it. One of the big things is you don't see a lot of red person's got a boiler system, that boiler system is not sized for cold water temperatures. And so you have an air to water that might put out 120, 140, but if the system is designed to run at 180 degrees water, that will never supply.
Well, yeah, you have to replace the boiler baseboard.
Yeah. But even if what he's saying is also comes back again to load sizing, right? And correctly sizing the distribution system. Whether it's a duct system or it's a baseboard system, what he's talking about is the temperature of the water is going to determine when it goes out there how many feet of baseboard it needs to condition that room. And you need to calculate that correctly if you're going to do air to water. So it doesn't matter whether you do baseboard or you do ducts, or it has to be sized correctly, and the distribution system also following the ACA process. Otherwise, we're not going to be successful. Okay, everything starts with the load calculation. And all systems require this, right? This is not unique to cold climate air source heat pumps. When you get called out to a job and they have a comfort problem, a comfort complaint, is it always a cold climate air source heat pump that's there causing the complaint? There probably aren't very many out there yet, right? Furnaces, boilers, any type of appliance that you have, regardless of the fuel, if it's not designed and installed correctly, there is a potential there that it won't deliver comfort the way it's supposed to, and you will get complaints. This applies to all systems, not just cold climate air source heat pumps, okay? If we design it correctly, we can ensure comfort, efficiency, and durability. Okay, they can work here. I have a person that I worked with, his name is Bruce Harley, he lives out in Vermont, and he's been heating his house with heat pumps since like 2000, okay? And you know, his house is very efficient, his ducts are very tight, and he knows a lot about this, he knows how to do it, but this can work, right? But we need to do it right. And we don't have to be Bruce Harley to do it, we just need to follow the right process, and we can do it correctly. Now, when we do our load calculation, there's two different types of load calculation we need to do. We need to do block loads. Block loads are basically for sizing the equipment itself for either zones or the whole house, depending on whether the house is going to be zoned or not, right? So how big does the system need to be comes from block loads. But we also need to calculate how many cubic feet of air per minute and how many BTUs per hour each room needs, because that's how we're going to figure out whether the duct system works or not. We figure out how much heat needs to go there, and then we look at how many CFM are going there at what temperature, and then we'll know whether or not we can supply the heat to that room successfully or not. Okay, electrical service requirements. This is a place where it would probably be a good idea, if you're not comfortable with this or have a lot of knowledge about it, to bring in a licensed electrician, right? To have that subcontractor to do this part of it for you, okay? We want to look at the house and the duct system and decide whether or not we could get better comfort by rezoning it some other way, okay? A lot of duct systems just, it's connected to an air handler, and it serves, 1,000 feet or 1,200 square feet, something like that. And it might be that with these heat pumps now, with their smaller capacities, we can break that duct system up into smaller zones and serve it with a stage of capacity and very closely match a couple of rooms' loads to a stage of capacity, right? And if you can match the capacity very closely, you get much better efficiency and much better comfort, okay? So that's really what we're trying to do. Okay, so location of the installed equipment is kind of important also. The outdoor units are more quiet than they used to be, especially the mini split ones, right? But they're not like dead quiet, right? You can still hear them. They kind of have that whine too. So if they're too close to where the people want to be, then it, obviously it kind of ruins their outdoor space. We also need access for maintenance, right? Okay, so this is a house that has a couple of mini splits installed on it. And we can see that when they installed it, they stuck it right there. Is that a good place? I guess the homeowner can always pick up their bricks and go somewhere else, right? Yeah, that's, think it through, right? That didn't have to go there. This is a really small house. When we place units, one of the things we always have to think about is the length of the refrigerant line set, because it's limited. They can only go so far and up so far. But this is a pretty small house, and I think that probably that thing could have gone just about anywhere, right? It didn't have to go right there. Don't do that to the homeowner, right?
So why do you think they put it there?
Was easiest?
Even though they had it extending the line out?
Well,
No, actually, you can run into
I guess they could have put it there.
horizontal loop.
Why?
Because if you make the line set too short, the equipment will not work properly.
It has to do with charge, right? The line set comes with a certain amount of charge in it, or the system is set up, excuse me, with a certain amount of charge in it, and it's matched to the length of the line set. So when you open up the line set, it fills it, and then the charge is correct. If the line set is, as he says, if you make it too short, when you charge it, it'll be overcharged now. So it matters.
Does that happen a lot, or you have to do an extra loop to get the line long enough?
I don't know. I'm not an installer. I hope not, but it'd be better that they do that than, overcharge the system, right? Okay, but so choose a place where it's not going to bother the homeowner, and where the line set is not too long or too short, so that when it charges, they can always adjust the charge. That's part of the commissioning part at the end, right? To check the charge.
Manufacturers will tell you that there is a minimum line set length, and so it doesn't matter what the charge is, you can't go short.
Can't go too short. Yeah. Okay. I've seen long, but not short.
Yeah.
It won't work properly. The head won't have the BTUs that it's rated for.
Yeah, you always want to stay inside of the manufacturer's specifications. You never wander out of those. And if they say too short is bad also, then don't do that either. Okay, and we want to think about reworking the duct system and consider zoning. Like I was saying, like the one-to-one matchup is one thing if you've got a really big room and it's got, if this is 3,000 BTUs of heating required here, then a one-to-one matchup is okay. But if we get into a smaller house that has like maybe 3 bedrooms grouped together, we've done all types of deep energy retrofits, and the load over here is really, really small. It's only 700 or 800 BTUs per hour. We don't want a 3,000 BTU head in there. It's too big, right? It's still too big regardless. So what we can do is we can come to a small air handler with very short duct runs, and one stage of capacity can serve all 3 of those or all 4 of those rooms, right? And that more closely matches it to the load on the room, which is our goal, right? Not to oversize or undersize, but to exactly size it if we can. Okay, so let's wrap up by talking about customer expectations, right? And so it's a good idea in that initial meeting to set their expectations for reasonable outcomes, right? And that way, when things actually go the way you said they probably will, then they expect that. If you don't set reasonable expectations about savings estimates and disruption and that sort of thing, then when things start happening that they didn't expect, then they may get angry, right? Sometimes customers think that this is going to be a simple swap out. 20 years ago, my HVAC guy came out, he took up my old furnace, he stuck a new one there. 20 years later, we're still good, right? That's not going to work with the heat pump. It's probably not going to be a swap out. That'd be pretty unusual. Again, mention the cooler delivery temperatures, okay? If they know that up front and they're expecting it, they won't be upset about it when it happens. But if you don't warn them, and then, so why didn't you tell me that I wouldn't have done this? Now we're in a bad place, right? So it's better to be upfront with the customer, take time to explain everything so they understand what the differences are between their new and old system. Heat pumps don't recover very well from temperature setbacks. Okay, that's one of the things about them. You get a furnace and it's blowing 130-degree air, and you can recover in an hour and a half, something like that. Heat pumps blowing 100-degree or 95-degree air into a space that's 10 degrees cooler than it needs to be, and it's cold outside. It's going to take it a while to catch up. Okay, so typically we don't set back heat pumps. Okay, remember here we're selling comfort, not just it's going to come out of there 130 degrees. It's going to be great. That's not what we're selling, right? We're selling a more gentle system that will keep their house at 70 degrees without them even realizing it's on. And that's the best HVAC system, right? It's the one that keeps the house at 70 or 75 when you're cooling, and you don't even realize the system is on. You're just comfortable, okay? If you know your system is on, then something's going wrong. Okay, and then also review the maintenance requirements of the system. Gas systems, typically, you can service them like every 2 years. Oil, they say once every year. Heat pumps, probably every 6 months whenever you change season. You want to have somebody take a look at it, okay? And then make sure that all the manuals, specifications, rebate information, all that sort of stuff stays with the customer.
Can I ask another question? So
Sure.
I had a customer that was telling me they wouldn't install ductless in lower income housing because they weren't robust enough, that they turn yellow or
Well, I mean, I guess that's his point of view, really. It'd be hard to talk him out of that if he believes that. You know, is that really his thing to decide whether what should go in there? I mean, it's more up to you, isn't it? If you're the designer or the homeowner or the owner, or you work for like a government agency, or yeah, yeah, it's not for him to decide. It's get a different contractor. That's all I would do. If you don't want to do it, we'll get somebody who will, and we'll make sure they do it the right way. You can't tell low-income people they can't have the heat pump because they smoke or something.
Kind of an contractor. Like, I'll sell you anything you want, even if I think it's a lousy idea. All right.
Yeah. Yeah, I would find a newer qualified contractor to do the work. That's what I would do. Okay. Other questions? No? Everybody's good? Okay. Well, thank you for coming.
What was CST?
What is CSG?
CST.
Oh, combustion safety testing.
Oh, okay.
Yeah, sorry.